This is section 7.1b, linear and nonlinear systems of equations. So as I said in the last lesson, there are three ways to solve systems. The last lesson we talked about substitution. There's also graphing and elimination. Today we're going to talk about graphing, solving systems by graphing. You'll definitely need to have your graphing calculator with you and the instruction manual for it in case you need it. If you don't have the printed instruction manual, try to find one online. Usually calculators have manuals in PDF format or some other format online. So this is one particular system that we could solve graphically. X minus y equals 2 is one equation, and x over 2 plus 3y equals 1 is the other equation. And the reason I'm showing you this image is just to kind of illustrate what a graphical solution is. It just means that the intersection point is a solution because that point satisfies both equations. So for here example, the ordered pair 2, 0 satisfies equation 1, x minus y equals 2, and it also satisfies equation 2, x over 2 plus 3y equals 1. And you can plug the ordered pair 2, 0 into each of those equations to prove that to yourself. But the main thing to remember, or the main point, the main point of this graph is that the intersection point is the solution of this system. This is a system then that has one solution because one ordered pair satisfies the system. Here is an example of a system. This is a nonlinear system because one equation is not linear, the other is. And in this nonlinear system, we have two intersection points, and that means that there are two ordered pairs that satisfy this system. And you can again prove it to yourself by plugging in 2, 1 into each equation, seeing that it works, and then you could also plug in 0 and negative 1 into each equation and see that it works. But the point is that there are two solutions to this nonlinear system, and those two solutions correspond to the two intersection points. Here's an example of a nonlinear system that has no solution. And graphically, that means that there are no intersection points. There's no ordered pair that satisfies both equations. So there's no solution, no intersection points. All right, now we're going to look at linear systems, and we're going to try to solve them graphically. So here's a simple linear system: 2x plus y equals 5, 3x minus 2y equals 4. Now, I know that you can solve this with substitution, and you can also solve it with elimination, but I'd like you to solve graphically because that is what this lesson is about, and you need to learn how to do it. So solve this system graphically. And quite simply, all that means is graph each equation and see where they intersect. That's exactly how to solve graphically. So graph each of these equations. They're both lines. And then see where they intersect, and you'll have your solution. Pause the video. Do that on your own with your graphing calculator. You can also graph it on graph paper if you don't have your calculator with you, but you definitely need the graphing calculator for this course. So if you don't have it yet, you should get it as soon as possible. Pause the video, do this on your own, and resume when you have an answer. Alright, so if you graph each of these lines, you'll get something that looks like this. This is the graph of one line, y equals negative 2x plus 5. That's the first line. And this is the graph of the second line. Y equals 3/2 x minus 2 is really the same as 3x minus 2y equals 4. Okay, the second line, 3x minus 2y equals 4. If you simply solve for y in that line and put it in terms of x, you'll simply get y equals 3/2 x minus 2. That's the mx plus b form of a line that's easy to graph. And once we have our two lines graphed, we can see that they intersect in one point, and that point is 2, 1. The point 2, 1. That ordered pair is the solution for this linear system. And we got it graphically. Moving on to another example. A new book company invests $6,000 in printing equipment. Each book costs $23.20 to make and sells for $35.20. How many books must be sold to break even? All right, now most of you probably know what break even means, but just a quick review to make sure. Let's first set up the equations. Our cost equation is 6,000 plus 23.2x. Now, where do we get that? Well, they had to invest $6,000 in the beginning, so we know that that's part of their costs, is what they spent on equipment. And then we add to that the amount that they spend on making each book. So if x is the number of books, then 23.2x is how much they spend on making books. So the cost equation, 6,000 plus 23.2x. The next equation is our revenue equation. Revenue just means how much money's coming in. How much money's coming in. And since the book sells for $35.20 each, well, the revenue equation is 35.2x. Now, what does it mean to break even? All that means is that your costs equal your revenue. So you spend as much money as you make, as much money comes into the company as goes out of the company. That's the break-even point. There's no profit involved. You know, you're not making any money, not gaining anything, but you're also not losing anything. So this is an important point for a business, the break-even point. And the question is, how many books must be sold to break even? So there must be a certain X number of books, at which my cost equals my revenue. All right, so I know that there are several ways to solve this, but I'd like you to solve graphically because you need to learn how to solve graphically and how to use your graphing calculators. So pause the video, do this on your graphing calculator. It's actually pretty difficult to do this on graph paper just because of the large numbers involved. But graph each of these lines on the same set of axes and find the intersection point on your calculator. Most calculators do have a function in which you can just find that intersection point. And it'll tell you exactly what it is. So take time to familiarize yourself with your calculators. It's going to be important to know how to use them. And that's part of your homework, is to learn how to use your own calculator. All right, pause the video, do this on your own, and resume when you have an answer. All right, so if we set up our grid, obviously we can scale the x-axis and the y-axis differently. You know that that doesn't matter. You can scale the x and y-axis differently. That's why the x-axis is scaled in hundreds and the y-axis is scaled in thousands. Of course, your graphing calculator takes care of that for you. Don't have to worry about it. This would be our cost equation, y equals 23.2x plus 6,000. And this would be my revenue equation, y equals 35.2x. And we can see that they do cross in a point. And again, you can use your function on the graphing calculator to find out that the exact point is 517,600. So x coordinate 500, y coordinate 17,600. That means that 500 books must be sold to break even. That is the break-even point. When I sell 500 books, my cost equals my revenue. And that cost and revenue is the y-coordinate, $17,600. All right, but to answer this question, you need to give the x-coordinate, since the x-coordinate represents the number of books sold, and that is 500. All right, now we're going to do nonlinear systems, and I'm not going to give you the graphs. You need to do those on your own. And nonlinear systems are even more important to use a graphing calculator for nonlinear systems, because when you graph curves on your own, even though you can sketch a pretty good graph, you might not get a completely accurate intersection point. So I encourage you once again, it is obligatory, it's necessary for this course to have a calculator, a graphing calculator, TI-83 and above. You could also have a Casio, although the TI-83 is preferred. And learn how to use it. You simply need to become familiar with your own calculators. So here's an example: x squared plus 4x minus y equals 7. 2x minus y equals -1. This is a nonlinear system. And you're going to solve graphically. And what you need to do is graph each of these functions on the same set of axes in your calculator, and then find the function for getting the exact intersection point or points. Pause the video now, do it on your own, and then resume when you have an answer. All right, so here's the answer. Notice that I'm not giving you the graphs, because at this point you should be able to do the graphs on your own, either manually or with your calculator. And if you graph x squared plus 4x minus y equals 7, and on the same set of axes you graph 2x minus y equals -1, then you're going to have these two intersection points. The point -4, -7, or the point 2, 5. Both of those will work, and both of those satisfy this nonlinear system. Here's another example of a nonlinear system. Again, solve graphically. Pause the video, do it on your own, and then resume when you have an answer. And when you do solve this graphically, you'll see that there are no intersection points, and therefore there is no real solution for this system. Here's the classwork, page 504. Write those numbers down. Notice that 65A is all you have to do. You don't have to do the other letters on 65. It's just 65A. And also importantly, write down these directions. You're going to solve the first 6 problems graphically, but you will solve 73 and 77 by substitution.